So we look at the next example. So from the previous video, we have looked at the two application using the double integral in polar and in Cartesian, where you can evaluate the area of the region and also a volume of a solid using double integral in polar or in Cartesian. So another example, another application that we can have using the double integral, whether in polar or in Cartesian, we can evaluate the mass, the center of mass and moment. Okay, so this is more to something related to physics. Okay, so in this case, I do want to explain in detail what is the physical meaning for the mass, center of mass and moment, but then I just show you a bit on the notation and also the terminology. Okay, so in this topic or in this application, you will see some terms where you can see the word of lamina. So what is lamina? So lamina is something a surface in 3D. Okay, but then the special of the lamina is it is a kind of solid where it is like it looks like something in 3D. But then because of this solid is very thin and sufficiently flat, so we assume that the lamina here is just like a curve on 2D. Okay, so meaning that what you have to understand here is, if you can see the word of lamina, so then we should bear in mind that the formula or the mathematical method that you have to apply is about double integral. Okay, where we have something on 2D, okay, two-dimensional system. Okay, and you can also find the word density in this section, in this topic. Density given by the delta in terms of the variable function. Okay, so the density here I would say is just like if you have double integral, so it's will be in the integrand part. Okay, so in this topic we interested to compute the mass. Okay, the mass where it is given by the small m. So there is a formula that you have to apply, so I will show you later. So this one is a quantity of a matter in a body. So in this case, I'm not going to explain in detail the physical meaning of the mass. You have to find it yourself. The thing that I want to highlight here is only the computation. Okay, so you also have the moment of mass, where the moment of mass here is given by the capital M. Okay, so and you can also find the word of center of gravity or the center of mass, and you also have the word of centroid, and you have the moment of inertia, which is given by I. Okay, I will show you later about the formula. So this one we use the mass small m, and the moment of mass we use the capital M. Okay, so this is the formula that you have to know, and as far as I concern, all the formulas here are not given, okay, during the exam. Okay, so here what is the formula? Now we just focus on the mathematical computation to obtain or to evaluate the mass, the moment of mass, the moment of inertia. Okay, so we have to compute the mass, so given by the small m, where the formula here is given by double integral, and you can see here your density, your integral is actually your density function. Okay, so now you have to know you have to understand the terminologies used, okay, so that you can substitute into the formula, where the formula is double integral. Okay, and the process to evaluate is actually the same as you done in double integral, you have to find the order of integration and you have to find the limit, and then you just integrate them as usual. Okay, and for the moment of mass, which is given by capital M, so this one it can be either respect to x or respect to y axis. Okay, because we have on 2D, so we only have the y and the x. Okay, so the moment of mass respect to x axis or respect to y axis. Okay, so if you want to compute the moment of mass about the x axis, so you have to plug in y. Okay, you can see that the formula for the mass and the moment, they are exactly the same, looks like the same, but only for the integrand part is different. But for the moment of mass, you have to multiply by whether y or x. If they ask for x here, we have to put y. If we ask for y, then you have to put the x. Okay, so that is the moment of mass. Okay, just now we have a center of mass or the center of gravity. Okay, so we have a gravity. Okay, so normally we put the bar here, so just to let us know that this is about the center of mass or the center of gravity. Then you have to use the moment of mass divided by the mass. Okay, so meaning that if the question asking for center of mass or the center of gravity, so first you have to compute the mass first, and then after that the moment of mass, and then you have to divide them. Okay, so meaning that if your calculation whether m or the moment of mass you got something incorrectly, so your center of mass also will be affected. So you have to be careful when you compute them. Okay, so if your density function here, whether this one or this one, okay, because when you want to compute the center of mass, you need this formula, right? And you must have the density function. So if your density function is constant, whether it is equal to 1 or whether it is equal to k, so the term which is namely as the center of mass, so we can say that this one to be a centroid. So just a name, okay, but the procedure is the same. So if our density is constant, then the center of mass becomes centroid. Okay, so maybe the instruction said that find the centroid of the given etc. So we know that the density function for this problem is constant. Okay, so this just some of the summary. Okay, so let's say your the density function is equal to 1. So this one only equal to 1, but not k. Okay, but if you have k or any value, so suppose there is a value somewhere, whether k or any value somewhere in the formula here. So now let's say your density function is 1. So as we know that for the formula of the centroid, so you have my over m, where the m here is just this one, right? Okay, and then for my, so my, this is the formula, you have the double integral of x density function. So that's why we have this. Okay, and then because of your density function here is equal to 1, so this one is 1 and this one also 1. So then we can simplify the form into this one, this expression. So 1 over double integral of the 1 dA, it is this one is actually the area of region. We have done this before, right? So we have 1 over the area of the region and multiplied by the double integral of x dA. Similarly for y bar, so for y bar you have the formula the mx, the formula is mx, and mx is you have to multiply by y, so that is why you have the y here. Okay, and similarly we can simplify the form, this one, because the density is equal to 1. So the density is equal to 1, so we can simplify the form. So 1 over double integral of dA, this one is actually area of the region. So we have 1 over area of region and multiplied by the double integral of y dA. So So normally we don't memorize this. So but then it's up to you. Okay. But normally the important thing here is this one. You have to know how to compute the mass, the moment of mass, and the center of mass or gravity, and also the centroid. Okay, but if you can memorize this, so this is extra for you, because this one is only for delta equal to 1. But if you have delta equal to k, for example, constant k, and the k should be somewhere over here. Okay, so now to understand, so here it's just applying the formula and you plug in into double integral and so on. Okay. Okay, so look at the example 1. We have a lamina. So if there is a word lamina, then we know that you should apply double integral. But if there is a word a solid given by blah 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 blah, so you should use the not double integral but triple integral. Okay. Now you see, if there is a word a lamina, so it is understood that we have to use double integral to solve this particular problem. So you are given a lamina where the density function, okay, now this is not constant, x squared, occupies a region R. So your region is bounded by the parabolic and the line given. So the question here, you got two questions. Find the mass, which is the m, small m, and center of mass, which is, you have to find the x bar and then y bar. Okay. Okay, so firstly you need to because from the formula, from the question, we have to find out the mass, where the formula is we have to use double integral because we have a lamina here, the density function, and dA over the region. Okay, so so now the density is a function where we have x squared dA. So we have to have the region so that we can determine the limit here, right? So now the region is bounded by the parabolic. So this is 2 minus x squared. So this is 2 minus x squared. And then the line of y equal to x. Y equal to x. Okay. So for this question, what I can see from my previous student, they will get stuck to get the region, closed and bounded region. That is because of they what they always do is they just sketch the line of y equal to x till here. That's it. And then from there, then they do not know how can we have the closed and bounded region. So that is because of they just stop the line here. Actually, the line of y equal to x can be extended to here, and the blue line there can also be extended. Then we can have the closed region, right? Bounded by the parabolic and the line, which means that our R is lying inside here. Okay, so that is our region. But then because of, you can see the region is bounded by this point and also bounded by this point. Then we have to find the intersection point so that we can determine the limit of x. So how can we get the intersection point? So you have to solve the two lines or the two equations simultaneously, where you can have 2 minus x squared equal to x. Okay, so now we can transform into a quadratic equation where you have the x squared plus x minus 2 equal to 0. Okay, we have x squared here, minus 2, and then x. So this one can be right into x minus 1, x plus 2 equal to 0. Okay guys, I know that you can obtain the root of this quadratic using calculator. Okay, you can use a calculator just to show your answer, just to check your answer. But in a part of the step, you have to show it. How can you get that? Okay, because we know that there is a step to get that, whether you can use the quadratic formula, or you can use this form. Okay, so use the calculator only for checking. So all the step to get the answer, you have to show on the paper. So hopefully you understand that. Okay, so now we can rewrite this quadratic into this form. Okay, then we can get the value of x. It is 1 and minus 2. So now we know this one is supposed to be minus 2 and this is 1. Okay, so now we already have the region, we already have the formula, but now we know the problem is about double integral, right? So we have no problem on determine the mass. We already know the formula. So now the how can we integrate this? So you need to determine the order of integration, and from there you can determine the limit of the integration. So now you have to decide what is the order of integration that you can use so that your calculation becomes more easier. Okay, so I'm sure that you will say you will choose x constant. Okay, so because of your equation here is already in y equal to and y equal to x. So then you want the y to be function, so that x should be constant. So we have x squared dy dx. Okay, so now we have to determine the limit of the x and the limit of the y. Okay, so the limit of x, so you have to sketch the line. The line should be vertical. Okay, because you can see that the region is lying on the first quadrant, and also the second quadrant, and also the third quadrant. So we want to make sure that for all over the region, so the lower bound and the upper bound should be always the same. If you can see they are different, then you have to split the region. So in this case, now we want to check. So let's say we want to have the vertical line like this. So you can see the orange line is lying between minus 2 to 1, right? That is for x. So you have minus 2 to 1. You have minus 2 to 1. That is for x. And then for y, so now you look at closely the region that you sketch. So now you read y from the bottom to the top. Okay, so from the bottom, so this is the first point that you can see. If you put many lines, and all the first point that you can have is here. They are here, right? And that points, they are all belongs to the line of y equal to x. So you have to put the x as to be the lower bound. And then you keep going upward. So when you keep going upward, so that is the terminal point that you can have on the line that you sketch, on the line that you sketch the vertical line here. So all these points, they are belongs to the quadratic of 2 minus x squared. So y equal to 2 minus x squared. Okay, so now you already obtained the limit minus 2 to 1, and then x to 2 minus x squared. So now we can evaluate the mass, which is the double integral. Okay, so first we have to integrate respect to y. So x squared is a constant. So you have y equal to x and y equal to 2 minus x squared dx. And then we substitute the limit, the value of the limit. So you have 2 minus x squared minus x dx. So we expand to 2x squared minus x4 minus x cubed dx. Isn't it? 2x squared minus x4 minus x cubed. So now we integrate. So we have 2 over 3 x cubed, 1 over 5 x5 1 over 4 x4. So minus 2 to 1. Okay, and then we substitute. So we have 2 over 3 minus 1 over 5 minus 1 over 4 minus 2 over 3 minus 8, 1 over 5 minus 2 to the power of 5, 1 over 4 minus 2 to the power of 4. Okay, then you have to compute them using the calculator. Okay, so when you evaluate this, you have to be careful, yeah, because there are lots of terms here. Then you will get 63 over 20. So this is for mass. Okay, mass of the lamina, where we already answering the first question. Okay, now the second question asking for the center of mass, where you have to provide the x bar, y bar. Then when you look at the formula, you have to get the center of mass first. Sorry, the moment of mass, m. Okay, with respect to about the y-axis and about the x-axis, because the mass here already obtained. Okay, then you have to evaluate the my and mx. Okay, so that is our next task, to get the moment of mass with respect to x and respect to y. Okay, so next we want to evaluate the moment of mass. So we have to use the formula of this mx and my. So so the moment about the x-axis, so we have use a double integral, but we have to multiply the density function. So the density function by y, dE, okay, over the region. And also about the y, so we have to multiply by x, density function dE into region. Okay, so now if you look at the formula here, we have the r over the region r over the region r. So meaning that you can use the same region. Okay, so you can use the region that you have sketched in the beginning. So your limit also the same, but the changes is only for the integrand. Okay, so now for the first one, we have the density given is x squared. So we have y x squared, and then using the same order, we have dy dx, and the limit also will be the same, minus 2 1 and x 2 minus x squared, 2 minus x squared. And for the one moment respect to y, so we have used the same order and the same limit, x to 2 minus x squared. So but you can see that the changes is only now we have a different integrand, so the answer should be the same. Sorry, will be different as the mass. Okay, even though the region and the limits and the order are the same. Okay, so for this, for your practice, so I'm not going to solve this for you because this is about double integral and you have to compute yourself. Okay, so please try yourself, and actually the answer is given, so please compare your answer with the given one. So you will get for first your moment of mass about the x-axis, so you will get negative 9 over 7, and your moment about the y-axis, so you will get negative 18 over over 5. So then we go back with the question here. The question asking for center of mass. So the center of mass is x bar, y bar, where we have the formula here for x component my divided by the mass, and for y component we have mx over the mass. Okay, so when we substitute, so my we obtain negative 18 over 5 divided by the mass is 63 over 20, and then the mx you will get negative 9 over 7 divided by 63 over 20. Okay, so when you evaluate that and simplify, so you will get the answer will be okay, you will get negative 8 over 7, and the y you will get negative 20 over 49, which means that you have to evaluate. When you evaluate, you will get negative 1.14 and negative 0.41. So that is your center of mass. Okay. So now we have done on one example regarding the application of double integral in Cartesian, where we have the situation you have to compute the mass and the center of mass. So in this case, there are lots of formulas that you have to remember. Okay, and as far as concerned, if you have physical exam, final exam, and the formula for this they are not given. Okay, so we will look at another example on the following videos.